Okay. Chapter 1. Chapter 1 focuses on mass and measurement. Matter and measurement, sorry. When we say matter, what exactly do we mean by matter? What is matter?
Solid.
Solid.
Anything that has mass.
Anything that has mass.
And takes up space.
And takes up space. Good. What do you think measurement is? Think about it.
Anything that you can measure.
It's anything that you can measure, but think about if you can link it to matter, what do we think it is?
How much space
It's how much matter you have. Okay, this is what our measurements are going to tell us. Now, when we say chemistry, what do we think chemistry is?
Science.
Science, the science of what though?
Measure.
The study of matter,
Its composition.
its composition,
Structure.
structure,
Properties.
properties, and what else?
Uses.
The behavior, something else that happens.
Reaction.
The reactions or the transformations that it undergoes, okay? So chemistry is a science that deals with the composition, structure, and properties of substances and the transformations they undergo. When you say transformations, that's just the reactions, okay?
Wait.
Yes.
Do we write it different than what you have on the lab? Because I started writing your lectures out already. So do you write it differently?
So in terms of what? What we have
You
here?
a little different, yeah.
So this is the definition of what chemistry is,
Okay.
right?
Yeah.
So how you want to define it, you want this specific definition.
Okay, so then not the one you have on the lectures.
So what I have in the lecture, it should be that comes directly from the book. This came directly from the book, right?
Yeah, but it's a little, that's what I'm saying, it's a little different.
How different is it? Tell me what it is.
It's a little, not too different. It just says, in this science, we study the matter, its properties, and its behavior.
So this is just a more detailed description of what chemistry is, and that's fine.
Okay.
Okay. Now, when we're talking about chemistry, there's some things that we actually have to understand. Matter, its properties, and its behavior. What is matter? We just said what matter is. Matter is anything that has mass and occupies space. Then what is mass? Mass is a measurement of the amount of matter in an object. Alright? So here, if we take, for example, my clicky thing versus my marker, which one will have, what can you tell me about the difference between these two? Which one? You gotta tell me which one. My clicky thing, what about my clicky thing?
It's heavier.
It has more mass than the marker because
More space.
it takes up more space. Okay? We ain't get to density yet. Now, matter. What is the building blocks of matter? Atoms. Atoms are the building blocks of matter. Now, each element is made up of the same kind of atoms. Now, what does this mean? So let's say, for example, you have your hydrogen element. Your hydrogen element, what I want you to think about is it as this little rectangle. That is your hydrogen element. Inside of your element, you have tiny little things. These are your atoms. Do we understand that? Great. So, every element will have its own individual atom. Meaning, your carbon element only contains carbon atoms. Your aluminum element only contains aluminum atoms. Alright? Now your elements are the simplest form of matter. When we say the simplest form of matter, what exactly do we mean? You can't break it down into anything else. Once you get to that element, a single element, that's the lowest that you can go. You cannot get anything other than an element itself. Atoms are the smallest object that retains the properties of an element. What does this mean? If you have a carbon atom, it has the same properties as the whole carbon element. You get that? Okay. Now, molecules. We have two types of molecules. Molecules are the smallest physical unit of an element or compound. Now, we have two types of molecules. All right? Here, molecules, you have two or more atoms coming together. So you have two types of molecules. These are two different things, right? So what do we think is the difference between these two molecules? Karen, what's the name of this?
Oxygen gas.
Oxygen gas. This is not oxygen. This is oxygen gas. There is a difference. This is oxygen. Anytime you see that subscript of 2, that signifies oxygen gas. This is what you breathe. You cannot breathe on this. Okay? What's the name of this one?
Carbon monoxide.
Carbon monoxide. Now, when we get to naming in chapter 2, we're going to see where these things come from. Alright? Now, we have two types of molecules. Alright? You have a compound and an elemental molecule. In a compound, you must have at least 2 different types of atoms coming together. In an elemental molecule, you have the same atom coming together. What do we think of these two?
Oxygen gas is elemental.
Oxygen gas is an elemental. And carbon monoxide is a compound. We must know the difference. Do you understand? Okay. Questions, comments, inquiries? Alright, so here for example, if we're going to ignore this right here. Okay? What do you think this is? An element or atoms of an element. Right? What do we think this is? It's a what type of molecule though? We have two types, remember? Elemental molecule. What about this one? Compound. Why is it compound? You have 2 different colors. You have green and you have purple. And this right here, you have a mixture. You have put everything together. Alright? Questions, comments? Yes?
I know we didn't get to it yet, but the last one, would that be a homogeneous or heterogeneous mixture? Or would we have to know that based on a physical look or like physical description of how it would?
Well, we would remember. So if you're looking at the homogeneous or heterogeneous, you take a sample from the top, the middle, and the bottom. Alright?
It's uniform.
Right. So if it's uniform, you're going to get the same thing in the top, the middle, and the bottom. If it's different, you're going to get a different thing on the top, different thing in the middle, different thing in the bottom. And what's that one? What's the name of that one if everything's different? Very good. Okay? Now, we have our states of matter. Alright? We technically have 4 states of matter. First one is water vapor. What would the state be for water vapor?
Yes.
Gas. Alright? What about water that you drink? Liquid. Ice. Solid. There is one more state. No plasma.
Aqueous.
Who?
Aqueous.
No, I heard something else.
Vacuum.
Vacuum. No, vacuum is not a state. That's surroundings. Okay, we didn't get to surroundings yet. Aqueous. What does aqueous mean?
Underwater.
Something inside of that salt water.
You don't know what
That's what
to
I'm
do
talking about.
So, okay, bet. Let's say, back home, you got a little parch in your throat. Sore throat, okay? What do you do? What's your mama gonna tell you? Go in the kitchen and do something.
Salt water.
Salt water. Now, we have gas, we have liquid, we have solid. These things are pure substances, meaning that there's nothing in there but anything that is gas or liquid or solid. These are pure substances at STP, which is standard temperature and pressure. If you have something that is aqueous, like your salt water, what can you tell me happened to your salt water? What happened to the salt?
It dissolves.
Dissolved
In the water.
in the water. That is what
That's what's
aqueous.
in the
That's
water.
what this in the water. Come on now, you got to get up on your charades game. Okay? So your aqueous means it's dissolved in water. Anytime that you have something that's mixed together, that is not pure. If you have more than one thing in there, you have an aqueous solution. You get that? Great. Reading hot book.
Oh no, I just realized something.
What?
Like, cause a lot of the time, like back in lab, last semester, we were at like, when we balance the equation, we put like HCl and like stuff like that.
It was AQ.
Yeah, and then I just thought, oh, okay.
Yeah, that's
why
aqueous,
it's
yeah.
dissolved.
Yes, exactly. So if you see a hydrochloric acid solution, you're going to see HCl, AQ. That means that your hydrochloric acid itself has been added to water. Alright? Now, classifications of matter. Okay, some things that we need to be able to break things down. Alright? So, if you have a uniform composition, first thing you need to ask, is everything the same? So, if you have a container, you have something in your container, alright? If you take a sample from the top, from the middle, from the bottom, if you end up with the same thing in each of these sections, that means you have a uniform composition. For example, a glass of water. If you have water in here, if you take a sip from the top of the glass, you drink half, you take a sip from the half of the glass, you have the last bit and you drink that, what does it taste like?
Same thing.
Water, right? So now, if you have oil and water, all right? If you take a sample from the top, what you gonna get? If you take a sample from the middle, mixture of oil and water. You take a sample from the bottom, water. This is not a uniform composition. So therefore, tell me.
Oh, you want to finish that?
No, go ahead, tell me.
So like in the case of like say Kool-Aid now, right? Or like iced tea mix, can it be homogeneous and heterogeneous depending on how you mixed it, or like the dissolve? Like if you put sugar in there, right, and then you put like a little bit, and then like everything's all the same. Say you like one of those people that put mad sugar, and then like you gotta like scoop it out in the bottom of the cup and like eat it like it's pudding. So like, you feel me? You know what I'm saying?
Now, that again will be, which one of that would be? If you had, the little pudding sugar at the bottom, which one would that be?
The first one.
The first one?
No, that one.
This one, right? So this right here, this is a heterogeneous mixture. If you have difference in composition from the top, the middle, and the bottom, that is going to be a heterogeneous mixture. If you have the same composition throughout, this is going to be a homogeneous mixture. Do we get that? That's baseline. If you have a heterogeneous mixture, you're done. You don't have to go any further. But a homogeneous mixture, you don't have to figure out what's going on in there. Alright? So then, you have to think about, okay, what is inside of here? What's this, what is it made of? Do you have, think about, you have a glass of water versus glass of salt water. What do you think is happening? Which one would be a mixture? Which one is a pure compound? The water is a pure compound. The salt water is your mixture. Now, if you have variable composition, that means you have more than one thing in there. That gives you a homogeneous mixture. But if you only have one substance in there, that gives you a pure substance. Once you have your homogeneous solution or your homogeneous mixture, you're done for the count. You don't have to go any further. But your pure substance, you need to figure out what's going on with your pure substance. Your pure substance, now you need to think about, can you break this down into something else? What are the two things that what can you not break down? That's a pure substance. When you say pure substance, there's only thing with that one thing in there. What can you not break down? Element. What can you break down? Compound. Very good. So if you have a pure substance, if you can break it down into something else, you end up with a compound. If you cannot break it down into anything else, you end up with an element. Did you get that? Questions, comments, inquiries? Now, physical properties of matter. Physical properties can be observed without attempting to change the composition of the matter being observed. Meaning, if we have my umbrella, fancy little thing here, okay? You can tell me the physical traits of this umbrella. You can tell me that the handle is gray and clear. You have red dots, purple dots, green dots, blue dots, orange dots. It is clear in itself. Okay? You have done nothing to the umbrella itself other than describe what you see. These are your physical properties. Freezing, melting, evaporation of the substance. Okay? Any type of changes in states. We have to be mindful of our changes in states. These are all physical properties. You get that? Chemical properties. Chemical properties, you must do something to change the composition of your substance. For example, if you look at the flammability or its ability to react, if you burn paper, this is a chemical change. Ultimately, what you're looking at, if you have your paper itself, all right? If you tear your paper, what kind of property is this? Physical, okay? If you now set this ablaze, can you get this paper back? No. So what type of property would that be? Chemical. All right? Now, for example, when you the fizzing of a mixture of vinegar and baking soda. Has anyone ever done that in the kitchen?
Yeah.
What does it look like? What is it forming? Foam or bubbles. All right? This is an indication that you are creating something. What do you think bubbles signify? Don't tell me the compound, but something else, a more general statement.
Gas.
Formation of gas. Anytime you see fizzing or bubbling like this, you are forming a gas. Okay? Now, we have two other types of properties. We have intensive properties. Intensive properties are independent of the amount of substance that is present. What does this mean? What is the density of water? Do we know? Do we have an idea? Pete, tell me.
There you go. I feel like that is the answer.
-2.
1 gram per, 1 gram per milliliter. 1
There you
gram
go.
per milliliter.
Now, let me explain to you what my -2 comes in, okay? Now, if I come to Monique, I say, Monique, can I hold 20? What are you gonna say?
Depends on my pocket looking like that. Yeah.
Okay? But ultimately, you don't know what I'm asking for. It's 20 what? I can be asking her for 20 cents. I can be asking her for $20. I can be asking her for $20,000. Right? Every number that you're going to give me in this class must be attached to a unit. That is mandatory. Because if you just give me a number, I'm not going to know what this is referring to. Alright? So, on the exam, if you give me the correct number, but you fail to give me a unit, or you give me the incorrect unit, I'm going to -2. Now, I can't -2 verbally during class, so I will verbally -2. I will say -2, and that -2 needs to indicate to you that you have forgotten my units. Okay? Are we clear on that?
Yeah.
All right. So the density of water is 1 gram, roughly 1 gram per milliliter. If you have a cup of water versus a gallon of water, what's the density? What's the density of the cup versus the density of the gallon?
1 gram per milliliter.
It is the same thing. So density is something that is independent of the amount of substances present. Now, what is the boiling point of water? 100 degrees Celsius. You got that right? 100 degrees Celsius. Now, your cup of water versus your gallon of water. What is the boiling point? What's the difference in the boiling point? It is the same. Again, something that is independent of the amount of substance that is present. These are intensive properties. Got it?
Yeah, because I was thinking like, a drop of water, that's going to evaporate faster than a gallon of water.
That has to do with the amount of heat needed in order to evaporate. Okay?
But to boil 1 drop of water,
Right,
is
but
it going to be less than 100 degrees Celsius?
no, it's not. No, not necessarily. Because remember, it has to. That 1 drop of water still needs to get to 100 degrees Celsius. It's just the amount of time that it's going to take to get to there is much less than that of a gallon of water. So now you have extensive properties. An extensive property does depend on the amount of substances present. Let's think about the mass. The mass difference between my 1 cup of water versus my 1 gallon of water. Which one has the bigger mass? Your gallon. Okay? Same thing with your volume. Your gallon is much bigger than 1 cup. Alright? Now, physical changes and chemical changes. Okay? These tie into your physical properties and your chemical properties. Your physical properties These are changes that you're not changing your composition of your substance. All right? You can find these as your changes of state, changes in temperature, and your changes in volume. Then you have your chemical change. Chemical change, you are making a new substance. This is something that you did not have when you started. You are now something like combustion. Combustion is a fancy way of saying what? Burning, or something is blowing up. All right? Oxidation. Oxidation, you can think about oxidation as, but if you have a screw, you put screw in water, what's going to happen?
Rust.
It's going to rust. That is oxidation. Okay? Decomposition. Something breaks down. All right? You're making something new. This is a chemical change. Do we get that? Questions, comments, inquiries? No? You sure we got this? Okay? Now, a chemical reaction. A chemical reaction is simply how you're forming a new product. Here you have hydrogen. Ooh, tell me the name of this. What's H? Hydrogen gas. Hydrogen gas is going to react with oxygen gas under heated conditions, and you're going to produce water. All right? Now, you're going to have hydrogen and oxygen in your water, but you're not going to have hydrogen gas or oxygen gas anymore. You have made something brand new. Do we see that?
Yeah.
Great. Now, let's take some questions. Okay? Classify each of the following changes as physical or chemical. A match is burned. Tell me your name.
Bishaka.
Bishaka. What do you think?
Is it chemical?
It's chemical. Do we agree with Bishaka? Who said no? I heard a no. Chemical change?
Yes.
I think so too. Iron is melted. Tatiana,
Yeah.
what do you think that is? What type of
Iron
change is
melted?
that? Iron
I
is
would
melted.
say it's a sorry.
Physical or chemical change?
It's a chemical change.
It's a chemical change?
No, it's physical.
Physical? How you flip flop?
I say chemical.
I was gonna say chemical initially because iron is an element,
Iron is an element.
but it's going to stay the same. It has the same consistency
Why?
because iron is an element.
Yeah,
It's
but
like
iron
an
is melted,
element.
but iron is an element, but you're melting it.
But it's changing it's just changing the property. It's not changing.
But what property though?
Um,
Solid to liquid.
Say it loud and proud. Who said it?
Solid to liquid.
You're going from solid to liquid. That's a change in what?
State.
Change in state. Changes in states are physical. Good. Limestone is crushed. Juan.
Physical?
Physical? You sure? Nope. Tell me why you think physical.
I'm guessing right now.
No guessing. So think about it. Think about what's happening. Limestone is like a little chunk of stone, right?
Like crushing.
When you're crushing it up, what have you done?
Breaking it down.
You've broken it down into almost dust, right? So now, what have you changed?
Physical.
It's physical, because all you've done is broken it down into smaller pieces. It's still limestone, right? Now, limestone is heated, producing lime and carbon dioxide. That's going to go to
Chemical.
chemical. How do you feel?
Because you're producing something different.
Very good. You're producing something new. That's your lime and your carbon dioxide, right? An antacid seltzer tablet is dissolved in water. Rana. Chemical change? How you figure You see the Alka-Seltzer commercial, okay? When they tear open the pack and you plop it in the water, what happens?
Fizzes.
It fizzes. And what does fizzing mean? You're producing a gas. Did you have a gas before? No. So what kind of change is this? Chemical change. A rubber band is stretched. Physical. Why? Because it's stretched. It's still the same thing. Okay? That's what I got too. Okay? Did you get that? You understand?